please come on stage. It's on cloud computing. On empowerment of women. Perhaps we hear something. Spencer, please come.
Okay, I'm going to sit at the end here for this one. How do these work?
Could you please introduce the
panel? I don't know what the German is for tough act to follow, but whatever it is, that's what we got here. I'm afraid we're not nearly, well, with one exception, as attractive as the previous panel, but we're going to try our best to be interesting. Marissa? Let's get Marissa, let's get Russ Daniels, and let's get, there we are, Werner. Perfect. I'm going to, okay, good. Let me just, obviously Marissa's been up here doing an endurance contest here. She just had a cough drop, so hopefully we'll be able to make it through another hour. Marissa, you know, is from Google, which is in many ways, a lot of people think an archetypal cloud computing company in a certain sense, and we'll get into the question of just exactly what cloud computing is. Russ from HP, which he arrived at, he's actually, although people think of HP as a hardware company typically because you actually see these plastic things that say HP on them, Russ is a software guy, and HP is doing lots of fun things in software, so don't just assume that when you see HP, it means that he's a server guy. And last, over on the end, is Werner Vogels, who has just informed me of some very good news. He was named CTO of the Year by InfoWorld magazine for 2008, which is a big, big deal in the United States of America and the world. And he's got, I'll do the commercial for him so that he doesn't have to embarrass himself by doing it. He is deeply involved in something called Amazon Web Services, which is another archetypal cloud operation. It's utility computing, it's very successful, and so I think we've got a really interesting range of people here to talk about this literally vast subject. When we were just starting out, I tried to remember the first time I have a very clear memory of somebody, I think it was probably Sun Microsystems in about 1995, on a whiteboard, drawing one of those kind of network diagrams where you put the little box here and the line and the box here and the line, and then up at the top they drew this kind of dreamy little thing with loop-de-loops, that was the cloud, and that represented basically the rest of the internet, the part that you weren't diagramming in your little thing. And that image has somehow stuck around and now been pushed together with the word computing to make this concept of cloud computing, which has millions of definitions and everybody has their own. So one of the things I wanted to start out with was to kind of just, it's almost hopeless, but we're going to try to have everybody give a quick, what does the word cloud computing mean to you? Now, do you want to take a rest, or do you want to just jump in?
I can just jump in.
Okay.
There's no question that cloud computing is a really big buzzword, but it's a buzzword that really fits. There is a really large economic incentive for large internet companies like Google, like Amazon, Microsoft, Yahoo, to build really reliable server farms that run their own services. And once you've spent the capital investment to get low-cost infrastructure, low-cost bandwidth, really reliable computing infrastructures, once you have that available for your own developers to develop on, why wouldn't you open that up for other developers to build on it as well? Because it ultimately really pushes the web forward as a platform. And it's also really good for consumers. I think a lot of people don't think about how fragile their data is, the photos you care about, the documents and presentations you've worked a long time on that are stored on your computer that are as easy to lose as loss or damage or a malfunction with your own personal machine. If you actually surrender that to the cloud, it means that that data is reliable, it's accessible from anywhere with a password, it's redundantly stored, so it's very safe, and I think there's a lot of advantages to it. So while cloud computing is really a buzzword, this idea of storing data in the cloud, allowing developers to build on the infrastructure that's been tried, tested, and really pioneered by the large internet portals is a really real concept.
Okay.
That I think is very good overall for technology.
Russ, when we say cloud computing, what does that mean in your world?
Again, I think that this is an industry that's almost impossible to overestimate our ability to hype, to take some buzz term with currency and define it to mean almost everything. And then unfortunately, it starts to mean pretty much nothing. We've been doing that, I think, lately with the cloud. A lot of what people think about in enterprises when I'm talking with customers is really just the ability to get compute capacity in different forms, different ways to deliver the infrastructure that we use to do the things that we do in the industry.
So with Marissa, we had storage, accessibility, security. Now you're...
For me, I think that it's important to sort of step up from the technology. I'm a technologist, so I love it, but I think it's more important to think about the implications. And I think what the cloud represents broadly is the ability not just to communicate, to interact through the internet, but to remember, to store information, to capture those photos, to capture videos and music, but also things like your calendar, your schedule, your agenda.
So I mean, is it an all-encompassing? I mean, one of the funny, a cloud is I mean, it can be a thing in a specific like there's a little cloud over there, but it seems like this cloud is almost everywhere. I mean, it's in this device that I have in my pocket that's a phone is part of the cloud in a funny way. I mean, because it does, or isn't it? I mean,
So again, for us, we don't think of the cloud as being the replacement for everything that we already do. We don't think that it's we don't think the world's moving back to the concept of a mainframe, except now it's just different technologies. We think it offers, though, a new expressiveness. It's a new way to do things that you can integrate with and take advantage of. So the nice thing about that ability to remember stuff is that it allows you to be able to create a continuity of experience as people move across a range of devices, as they interact in a range of human circumstance. So now we have the ability to start to solve problems that if you're trying to solve in the traditional architectural approaches of enterprise applications or device-based application, make them work well.
And, well, just to extend that, I think the reason the word cloud really fits is that you don't need to worry about where it is. Right? It could migrate, the cloud you're working on may close one data center and open another, but the idea is because of the way that it's structured, it's reliable, it's there, but it could change and move, it's still accessible to you.
Now, although I do think, so the notion of location, transparency seems to be core to, at least from the consumer part of the cloud. However, for developers, as well as for legislation, it is very important that at a particular level, this transparency is taken away.
I don't want to let you off the hook for this because you guys actually use Elastic Cloud EC2, Elastic Cloud Computing.
Elastic Compute Cloud.
Compute Cloud is one of the elements of Amazon Web Services that I did that little blurb for, and so you've actually incorporated that word. So you got to give us a.
No, actually, that predated the whole cloud computing thing. So remember 2 years ago. We launched S3 and EC2. That was way before cloud computing was.
But what did you mean by cloud when you used it?
So I think there's a sort of a redefinition going on. So first of all, I think cloud computing is a buzz, is a marketing word, but we've been working very hard on actually trying to give it some meaning. And I think Gartner has a very good definition of it. That is, cloud computing is a way of computing that deals with massively scalable distributed IT capabilities that are provided as a service over the internet to multiple customers. And I think that as a sort of a generic statement works quite well. Because there's a few important parts in there. So massively scalable and distributed. That's core, I think, as a service over the internet. And over the internet can be public internet, but it could be also private ways, but at least it's a network. And it is multi-tenant, meaning it is provided to multiple customers. You can look at it as different layers. So in general, I look at it as 3 different layers. There's an infrastructure as a service. Those are the kind of things that Amazon provides through the web services. There's platform as a service, where they can have different programming models where developers work against. And then there's applications as a service or software as a service at a higher level. Each of those could fall into the category of massively scalable IT capabilities. And so I think that's my definition of cloud computing.
Okay, I mean, now one of the obviously massively scalable, accessible implies, I mean, one of the little terms, somebody mentioned that cloud computing is kind of the ultimate globalization concept in the sense that it crosses boundaries. That the cloud is not, for instance, many of the discussions yesterday about internet jurisdictions, where does data live, who owns it, all these kind of questions kind of come home to roost here, because if you've got this massively scalable thing, well, I'm wandering now, but let me put it this way: how does Google deal with the issue of jurisdiction of its portion of the cloud? I mean, how does that play into this?
So I do think that this is an area where the technology has really gotten ahead of the legislation and the policy, because the notion of the cloud, because it's amorphous, you don't necessarily know where that data center is. That said, you have to comply with local data laws. So for example, when we're storing user information, it is bound by the laws of the country that it's stored in. So be that the United States or the UK or somewhere here in Europe or Asia.
But in fact, I mean, if it's, does it actually matter? I mean, I know it legally matters, but technically it doesn't.
Technically it doesn't matter, but it does for the users who are signing up, who need to, what we're under. How will my data be stored? What are the laws that are guarding it, guarding privacy, those types of things? Those actually are bound by those specific countries. But I think this is somewhere where the policy and the legislation really needs to catch up with the way that the technology is actually being deployed and used.
It seems like, and I think both you guys have to deal with it, that there's a big gap between the reality that the location of data is essentially irrelevant and legal and other concerns that act as if it's very relevant, and they say, oh no, we want it here or we want it there.
But I think this, though, is there's a difference between design of technology and design of business models, and then design that satisfies social expectations. I don't think it's useful to say that it doesn't matter, because if there's legislation, it does matter. Right. The legislation's based off of concepts that are rooted around some sense of public good. And when you think about if you're a government entity and you're providing some services to your citizens, then you might want to have that capability being delivered within your jurisdictional boundaries for reasons of employment, for example.
But it is quite disruptive. I mean,
well, I think all these things are technology. You can't just imagine and design technology independent of the real world's requirements. You have to think about the business models, you have to think about the social expectations. I spent 15 years at Apple Computer, and during the time there, I saw some of the biggest technology train wrecks you've ever seen. We created wonderful technology, spent hundreds of millions of dollars doing it, but benefited no one. It wasn't because the technology wasn't cool, but it was because we were trying to do things that created problems with business models for the people that we needed to work with, or that required social behaviors that were outside of the norm. So you have to think about all these things and take them into account.
Well, but I mean, a classic cloud application, for instance, is peer-to-peer, BitTorrent, which is very disruptive. And I mean, even though every government in the world has at one time or another tried, and the music industry and everybody has tried to beat this thing into submission, and yet it keeps on going. And
but again, there you have to make the difference between the application of the technology and the technology itself. Yeah, I think BitTorrent in itself is a very effective transmission protocol. On top of S3, we provide BitTorrent capabilities. Why? Because it's just technology. Yeah, the fact that things are being used for legal or illegal purposes is a whole different matter. But coming back to whether it matters where data lives, yes, it does. Absolutely. And we work a lot with governments and legislation to try and understand what the implications of cloud computing are for their citizens. You know? It's very likely to be expected that it will need to be made explicit to your customers where they're going to store data. If you open up your email program, your web email program, that at one moment it will tell you, do you want this data to be stored in the US, in the UK, or somewhere in the EU?
But at the moment, I mean, I actually was thinking about that. I use Google Docs very heavily. And I was sort of sitting there in my room in the hotel, pressing save and wondering, gee, where is this going? Is it going to Mountain View? Is it going to Ireland?
Sure, and I think this is one of the issues that cloud computing is really straining from a policy standpoint, because is it where the data is stored? Is it where the data is served?
Right.
So if you're a citizen of the US, but you're here in Germany,
Right.
you're accessing your data in the US, should it be subject to German law or not? Right now it's basically based on where the data lives, but because
But it's
people
also,
are in
but
fact
by
so
the way,
mobile
I'm
right
going to make
now,
a
it
wild
makes
guess.
sense,
It's
so.
actually probably replicated in 4 different Google data centers.
Yeah, I think that's actually one of the most important things to think about with digital data is that it can exist in many places.
In
So
fact,
there's
I
a question.
hope it is, because if
Well,
it isn't,
There's a question about where's the authoritative source.
right.
Where's the copy that's the golden copy, the one that you depend upon? But there are very good reasons to have that data available in different formats. You might want to have the data local on a device, cached, because that provides the optimal performance for that experience, but still be able to have that data replicated to the cloud
Right.
so that you get all the advantages. I just want to mention too, there's a real problem with the technology approaches, because if things like replication or data synchronization get exposed to people, then you're now asking people to understand very complex, abstract design concerns that tend to make the technology unavailable to many people that could be.
You know, again, if you look at this as a stack, at the top layer of the stack, you want to have things as transparent as possible, because that's simple, and your end user, consumer, that's the way you would like the cloud to be, as a complete, transparent mechanism. However, for developers, you need to provide them with clear mechanisms, such that they can actually obey local laws. If they have to develop applications which says data needs to be stored in the EU, then you need to provide them with the mechanism.
Right.
So in EC2 as well as S3, we provide capabilities such as regions. Within regions, there are availability zones, and those regions not only follow accidental geographical lines, but also jurisdiction lines. And so you need to provide these capabilities in your basic model, such that developers can actually obey laws that they're being confronted with.
Well, assuming they want to. I mean, there are developers, again, you know, Pirate Bay or something, that specifically don't want to obey laws.
Sure, but remember, those are very small. They may get a lot of press, but if you look at the majority of the enterprise developers or consumer developers, right. You know, they do many things. How many AWS users are here, actually? Hey, look, these are people that run their business on our cloud services. Yeah, and I assume that most of them are legal.
Well, in fact,
any illegal...
wait, there's one. No, we just had one. No, there's one little hand just went out there. I mean, one of the interesting things about, I meant to say at the beginning that, by the way, the great thing about cloud computing is you can very safely say everybody in this room uses cloud computing services all the time, every day, anytime you do anything. I mean, it's practically impossible to be, I mean, you can't be on the internet today without, I mean, it's a curious thing. And obviously there are some things like web-based email that are, I would say, you know, cloudier than something just like search, for instance, which Marissa is, you know, I mean, search is a cloud function, right?
Well, search is how we built our cloud. So
Okay.
basically, we needed to be able to crawl the web, bring back copies of those pages, index them, run computations over them. And when you're trying to store copies of the web replicated multiple times, you need a huge storage infrastructure. Right. And we needed it to be very low cost. So we worked really hard to optimize it. And then when we were done, we thought, wow, we have a really great low cost storage mechanism. Let's use that for email, which is how Google Mail and Gmail were born, right. And then really extending that to a lot of the other things that we've done, like Docs and spreadsheets and Calendar.
Well, in fact, I mean, one of the things, Russ, I think, was the first one to bring this up, an aspect of the cloud that's really probably its single most distinct, it's not computation, it's not storage, all those things can be done without a cloud. It's communication. I mean, that's why, for instance, social networks are another archetypal cloud application, because you really can't do them without a cloud environment, I don't think. I mean, you could do it inside a company, you could have your own little, but the whole nature of these things. And so if we could just, I mean, one of the, you know, the cloud has been gathering elements. So for instance, one that's coming up very strongly now is location-based, okay? I mean, when you're on your cell phone, right now, the network does have the capability of knowing where you are, and that information could, in theory, and in some places probably is, being added into the cloud. I mean, you're kind of adding more and more layers of information to the cloud. And I'd be curious to where do you see, right now we have, email, we have web-based word processing, those kind of things. Where do you see, I want to ask everybody, the next sort of frontier in things that are going to be added into the cloud, either in terms of applications, in terms of intelligence broadly construed, or in terms of data, types of data that are going to be going into the cloud that are not currently there?
So your question kind of assumes that what cloud computing is today is a line drawn in the sand. Like this is a finished product.
Okay.
Like that we released version 1.0 and that was it.
Right.
It's not. I think this is a continuous evolving world. If you look at the world 2 years ago, Jeff Bezos was on the front page of Business Week saying Amazon's risky bet, where nobody actually believed that this could be a viable business to begin with. Now, a very large part of the internet world runs on our services. Yeah, and so in other businesses are being powered by it.
Well, for
so we continuously evolve this. Yeah, and we're all kind of making new steps. It's not like we've left this one behind, now we're going to work on the next version.
No, I know, but for instance, like Amazon collects lots of information about the purchases. Anybody who's an Amazon customer, okay, their purchase history is well known to Amazon, and you guys could make that available as. Is that the kind of thing
I think for this particular panel, I'd much rather talk about the web services stuff because that's much more exciting. I mean, what is the impact on the media world? Lots of media folks here. I mean, what are the new business models instead of rehashing sort of these old discussions?
I think this gets at that because if you're instance, like when Facebook did their Beacon program a year ago, which was going to incorporate purchasing, I bought this thing and putting it on my Facebook thing and letting other people know. Are we going to see much more, again, for instance, commercial stuff coming into cloud-based apps?
Let me just take a different angle on that, because it's true that Amazon captures a lot of information about my behavior when I shop there. It knows what I've bought. It knows what I've searched for. It knows, and it can take that kind of information. It also knows demographics because they know my zip code, so they can characterize my income, and then they can start to tailor tailor offers to me based on what they know about me and what they know about others like me. Well, but there's a very interesting thing, which is everything they know about me, I know too.
Right.
But I just, unfortunately, today throw it on the floor. I don't remember it. I don't keep track of it, so I can't use it for any interesting purpose. I think there's a characteristic of the cloud that has huge implications over time. And it's around the ability to capture a rich personal profile of yourself that you can use for your benefit, that you can make available to a broad range of services, so that this stuff can the technologies can start to identify your intention based on that profile, that understanding of your default behaviors, their expectations, your intentions, and it can transform the way that technology creates value. We can make this stuff so much easier to use simply by having the technology take more of the responsibility.
Well, I just have to say, I think that we've wandered into an area where we're talking about things that are very application specific. What Amazon chooses to do with the data they collect, or Facebook chooses to do with the data they collect, is very specific to those applications, right? And so yes, they will gather a lot of general data. It should be in the user's discretion how that data is used. But fundamentally, when you look at the cloud, it's just a really great way to build software. If you're looking at porting a piece of software right now or starting a new company, why would you say, buy a lot of computers or work really hard to achieve reliability? There was a recent study that came out that showed that, for example, mail that's run on the web generally has about 15 minutes of downtime per month. If you're running an Exchange server, you'll often have 150 minutes of downtime per month. So when you have internet companies that are very economically incented to have robust, reliable clouds and have a lot of storage and bandwidth that's accessible, it makes sense to build on top of it because it's just a better platform for building software. And that applies to all applications, not to specific applications and their data use.
And I actually like to combine these two things. So, your mention is that this data is available in the cloud. You have these highly reliable services that you can build upon. But it also becomes an environment where other platforms can be built in because other companies are playing there. So for example, on an AWS platform, many telco providers now come in and build their telco platform on top of AWS so they can serve it to other other developers that using the same platform. So you see other platforms being on top of, built on top of this because folks want to make companies want to make their services available in the cloud for reuse.
Yeah.
So you see many enterprises that move into the cloud not only to move their applications there to make use of because it's cheaper or it's more efficient or more agile, but also then they can look at what is the unique capabilities that they have and can they start providing those unique capabilities as a service to others in the cloud.
Well, I mean, scalability, I mean, in that Gartner definition that you gave us of cloud, scalability is a big, and one of the curious things about scalability I'd like to explore a little bit is there an imperative to scale here? In other words, are we driving toward, a world in which there are, there's the sort of Amazon cloud here, and there's the Google cloud here, and there's the Facebook cloud here, and people kind of end up in one, and they get very large. I mean, because if scaling really does happen, there's a suggestion that all the little ones get squashed, and you end up with a few biggies. Is that the world we're heading toward?
I think that the web really promotes scale, and I do think that scaling is really hard. I was there as we built Google's cloud, and we had 300 computers, and suddenly the next week we needed 200 more, and they didn't ship on time, and 50 disk drives showed up and they didn't work, and then you've got to return them, and the sort of the pressure of this, that the scale of the web puts on companies and on services to grow is really hard to respond to. So I do think there is sort of a gravitation towards services that have already done a lot of that heavy lifting, have already had that reliability and that scalability. And so I think for a lot of businesses, it depends on how you're using the cloud. It may make sense to build your own, right, depending on what scale and what type of thing you're building. But a lot of times it will make sense to build on top of an existing cloud because there's just really robust facilities
I think
there.
it's important to think about this in the context of roles. If your business, you can be a consumer of the cloud or you can be a provider of the cloud. So your question is, will there be, on the providing side, the service providers, will there be 3 companies or will there be 10 companies or will there be 100 or 1,000 or 10,000? When you think about some of the practical problems, first, these issues of sometimes there are requirements that the data be in specific locations. Those things can be for legal reasons, but it also can be issues around speed of light. The types of access to the data might require, the data locality didn't disappear because we introduced the word cloud. There's still things you have to consider. There's a lot of economic interest in being able to provide this. There's a lot of companies who have the basic capabilities to be able to build and deliver these kinds of infrastructure services. The large service providers, the large telcos and network service providers, they have a lot of capacity, they have a lot of operational experience. Companies like IBM, companies like HP that have very large businesses operating these kinds of data centers for our customers are other examples. Regional VARs, specialists around verticals. There's a lot of reason that companies can participate. There's fundamental questions around economics. I think a year and a half ago there was an assumption that this was a scale issue in the purest sense, which meant you had to build $500 million data centers and put them on top of dams with local municipal power that you could get really cheap to be able to compete effectively. But we think the technology is evolving in ways that will make that less true. You can buy containers, shipping containers pre-populated with gear. You don't have to know how to turn them on. You don't have to do anything other than plug in the network and the power, and up you go. And then it's a matter of software and automation and management, operational expertise to be able to participate. So the short answer is, we think that the world's going to be complex, that there will be continued reasons to see a decentralization that will push against the pressures of centralization.
Well, Werner, I was going to ask you, is there a migration path off Amazon Web Services? In other words, if a guy starts, one of these guys does a startup on Amazon Web Services and it blows up and gets huge, they kind of stay with you, don't? There's no...
yes. There's no reason. I mean, a migration path, why would you want to? No,
that's my
first
question.
First of all, the other question is, where would you migrate to?
Well, exactly.
So there's a few interesting stories there. For example, so Splunk is an enterprise application that takes log files, and so they have this interesting model where They normally sell their software to their customers, but they give it 3 months in use first before customers can make this decision. But they have to run it on a server and things like that. So Splunk has done this thing by, they run it in the cloud for you, and then after 3 months you can decide whether or not you want to buy it. Actually, when customers make the decision to buy it, they never move out of the cloud again.
Right.
It's not like that they take it away and say, no, now I want to run it on my own server. And regardless of what you say, you can build shipping containers and whatever, you have to put people against it, you have to have lots of folks doing it. I think scale is as much an economy of scale of people as it is of technology. Yes, we are a few companies in the world that actually really are capable of driving costs to the floor of their data centers, of really operating these things at scale, but it is also the intellectual capital that is there necessary to be able to run this. So, and if I look at many of the startups here that actually run on top of AWS, they do not have to think about infrastructure. They can think about building the best applications possible. The SoundCloud guys, are they here? So SoundCloud is a startup in Berlin. You should check it out. They largely run on AWS. There's the Mashery is here. All these other companies that are running on top of it, they can focus on building the best application possible to serve their customers, instead of having to spend all this time being system administrators. There is no value in being a system administrator. You do not build a better product by being a better server maintainer.
Now, when Marissa was describing the birth of Google and the, wow, we got to go get another 100 servers, run out and buy boxes. Are there implications for it being so easy now and so cheap to start? In other words, it took, when was Google? 10 years? How long has Google been around?
10 years
Okay.
Yeah.
Let's say it took 5 years to go from an idea to a really big company. In theory right now, with what Werner peddles, you could go from an idea to a very large company in 1 year,
well, even
6 months.
Overnight, right? We see on Google App Engine and on Amazon Web Services, there are people who launch, and the next day, because the scale is there and the capability is there, they just need to up their quotas. They can be serving 100,000 people, 1 million people the next day.
So
and I think that when you look at it, I mean, I think the trend will be, right now we have tens of thousands of services that are built on Google App Engine. Maybe 1 or 2 of those is a Facebook or a Google. You could imagine, for example, Google being built in the early days on Amazon Web Services, and when we later would come to the economic conclusion, oh, you know what, we're going to become big enough and the scale will be serious enough that we actually need to do this on our own, we could move out of their cloud and separately, but that will be the exception, right? The 0.1% or 0.01% case rather than the rule in terms of people who need to actually build their own cloud as opposed to building on an existing.
I really want to make a case because there's many media people here. Yeah, so media used to be an area that was also dominated by access to capacity, to the network, but these days we see many new media companies arising, totally from scratch, overnight becoming successful in ways that were never possible before. If you look at a company such as Mogulus, which does online TV channels, 120,000 live TV channels online, completely runs on AWS, has no own server infrastructure whatsoever. During the election results night, they ran, 80,000 channels concurrently streaming around, 45 gigabits a second out of Amazon EC2. This is a company that's a media company built completely from scratch, successful overnight. And yes, it's certainly, if you talk to many of the larger web properties now that are now more mature, if you ask them, would you have been built on Amazon Web Services if it would have been available 10 years ago? In general, the answer is yes.
Then let's turn it around. Let's just assume that we now have utility computing. It's essentially a commodity. The focus, unless you're an actual provider of those services, the attention then, in theory, should focus to other. Where is the focus? What's going to be defensible? Okay, if tons of servers are suddenly easily rentable with a credit card, owning tons of servers is no longer a business advantage. In fact, it might even be a liability.
Well, I think that's the beauty of it, right? It then becomes about the idea. It becomes about the application. It becomes about how well you're meeting your users' needs, right? And you can actually focus on that as opposed.
I'd just like to inject one small moment of what I think of as pragmatism might be something different. What's the total amount of compute capacity today that's being delivered on mainframes? And is it growing or is it shrinking? So surprisingly, it's growing. It's an architecture from 1965, roughly. We get so caught up with the new things, and it's exciting. Trust me, I'm a lover of the new myself. But there's also a lot of stuff that's happening that's not going to go away. And the reason it's not going to go away is because it produces real value. HP, it's this little startup company that I work for, has a $60 billion plus supply chain. In other words, we buy over $60 billion of stuff to produce the over $100 billion of revenue that we deliver. That stuff we buy is typically in the hardware products, printers and servers and desktops, et cetera. Those supply chain management capabilities are fundamental differentiations of our ability to succeed in the market, to create value for our customers and to create value for our shareholders. And they're not going to migrate anytime soon. Why? Because we're really good at it. Because the economics work out really well the way that we're doing it today. So I just think it's important to keep a balance. There's a new thing that's happening. This thought that all of a sudden in 2 years we're going to throw a big switch and all the compute happens in these few data centers managed by a couple companies, I think is unlikely to be true.
But I disagree there with you in that, so for HP, your supply chain is indeed your key differentiator. But for 95% of the businesses out there, so their supply chain is just a pain. If someone would provide them supply chain services as a service, they would gladly use it and focus on other pieces.
So if I could, I think that first there's a lot of manufacturing companies, and I think SAP would have a different perspective about the importance of supply chain management in the industries. But I think that the cloud offers the ability to do something that's much more interesting. It isn't, when we think about the way that we design software today, there's a concept of design of the application itself, sort of the logical architecture which describes an implementation. And then over the past 20 years, there's been a lot of focus on enterprise architecture, which is to understand the architecture of the business itself. And it tends to be focused on understanding its business processes. The cloud's exciting because it allows us to expand away from just thinking about how a business works to think about how that business works in the ecosystems in which it participates. You have the opportunity to pull the design up another level and not just think about HP in isolation, or not just think about BMW or Audi or a car company in isolation, or any of the others, but think of them in the context of their complete ecosystem, from the customers all the way back through their channels, their partners, and their extended supply chain, all that depth. And the cloud's a great place to bring together the integration, the automation of those things. Trying to solve those problems in traditional architecture approaches has been dreadful. Enterprise application, not an easy thing to do, not an easy thing to do well. Most of those projects take longer, cost more, and deliver less than expected. If you try to bring those kinds of things to the cloud, you get a fundamental different answer.
If I could just bring this back around to the data question, okay? Because we're really talking about two different kinds of scaling here. One is scaling, technological scaling, servers and all that stuff. There's also the issue of information. For instance, I mean, Google keeps a ton of information. It's a bigger pile, and in fact, one of your key assets is that you know a lot about a lot of people. Same, you know, and Amazon, same. I mean, that is a key differentiator. And Facebook, this issue of who owns the data, whose is it, how does it exchange? And in fact, I mean, you could at this point, for instance, farm out all your servers to somebody else, to Amazon Web Services, but you would still keep that core of what's in the storage, what's there. That's what makes, for instance, a Google search more effective. The algorithm is nice, that you have a nice algorithm is a good thing, but it's also really important that you know who I am. Am I right?
Well, it's both, right? I mean, the algorithms that run the search and run all of our different applications are important. The data is really important
but
too.
But if
and
you took away all your
more,
data, you'd be...
Well, I think that, for example, there's some applications like a lot of our search services that don't have a lot of user-specific data. There's personalized search,
right.
But it's a small part of it. But when you look at, for example, our overall app strategy with Gmail, Calendar,
right.
Docs, and Spreadsheets, Picasa, those apps really run and largely exist to operate on people's personal data.
Right.
Right. So we actually think that those are great services. They really free people up from being tied to their computer. And we also think that it's basically versionless software, and you also have, that we can constantly update it and make it better. And it also eliminates a lot of the problems with collaboration in terms of version control. You know, people used to have to send around documents and retitle documents with the date or the draft number in them. And now if you actually store it in the cloud, you can all be looking at and collaborating on the same version and doing updates and seeing those refresh immediately. And it's just a much more seamless way of doing a lot of what businesses need to do.
Well, let me put, I'll be a user, okay? And I now have piles of information about me at Google, at Yahoo, because I use Yahoo Mail, at Amazon. There are little piles of Spencer scattered all around the world. From a certain point of view, that's disturbing. Some people don't like that. I kind of look at it and say, well, wait a minute, I really wish they all talked to each other so that somebody had a complete picture of me instead of having this little shreds. The cloud could technically do this. I mean, you can use APIs. Do you think we're going to move in that direction of more open, holistic information about people rather than having islands and silos of information? Anybody want to?
If I could, I think this is a great example where, first, I think the question's fundamentally one of software design, and it has a significant implication around business model design. If you think about just the contact information that we all have. I bought a car, it has an entertainment system that has Bluetooth, so I can use it to do voice dialing. But to be able to dial by name, I have to put my contact information into the car's system. That depends upon the car and the phone both implementing a complex Bluetooth profile correctly, and they don't, which means that there's really no practical way for me to get that data into the car.
Are you pretty confident somebody's going to do that?
Well, but let me explain. The design is flawed, because this design presumes it's flawed in two ways. One is it depends upon a device-to-device protocol, where it should be using the well-established internet protocols that we've bulletproofed in the industry. And it's also flawed because it assumes that the contact list on my phone is authoritative, but it's not. It's just copied information from Outlook and Exchange. But that's not authoritative either, because I work for HP. We have a global address list, which is propagated into that, but doesn't integrate particularly well. But that's not authoritative either, because I use Gmail, and it has contact information. I'm a customer of Grand Central, which is an acquisition that Google did. That's a different contact information. I have about 10 different things in my life that all think they're authoritative for my contact information. None of them do the thing that they should, which is ask me, what is the URL for my contact information? And then that's where they get it from. They can cache it locally if they want. They can proxy it for something else if they want. But it always needs to come from one place. If we don't get, and by the way, that in turn can then federate beyond to handle all the things like global address lists. But this is a design concern that we have to get right, and it has a business model implication because, unfortunately, many businesses, the way they try to monetize this free services they deliver is by owning your identity, by owning your information. And I have this very simple perspective that actually I own it. It's mine. And I think that when we think about services, we need to think about what services mean. They're assistants. They help. They serve you. They don't own you. They serve you. And I think that we have to work through these issues so that we can get this kind of stuff to work together.
I want to make we just got a little time bump, and we're down to 10 minutes. So if anybody has a question, put up your hand.
Yeah, I want to follow up on this one, actually, and that also ties into here, because you say these many different data sources. Russ gives the example of your address book. So I think there's room for many different aggregators of data, but most of those aggregators could be niches. Actually, for your particular problem, there's a great small company that runs on top of AWS called social.com. SOOCIL. They do exactly what you want. Aggregate all your different contacts, all your different address books, and give you complete control over how to manage.
But they can't make all those applications that I depend upon. I'm saying there's a fundamental mistake in design, which is we have these applications that capture data and then treat it as if it's all theirs, and it makes the user experience, again, because all these different applications have this information, then we're left with great user experiences that say, do you want to replicate the data? If there's duplicated copies, which one do you want to, if they're conflict, which one do you want to trust? People can't figure this stuff out. It's too hard. It's bizarre, and it's based on bad design of technology. And we have to take advantage of the cloud, not just to be able to do things more cheaply, but also to do things better. That's the key.
I also think that that calls for standards. which really need to happen across the industry. You need to have APIs that, so people can understand, okay, how can I access your contacts list? How can I access this data about you? Because the data really does belong to the end user.
Do you think someday that Google and Yahoo will talk to each other and commingle my profile?
Well, I think that I think that we may have a protocol for doing that. I think whether or not we do that is still going to be your decision. But
if I wanted to, I'll be able to do that someday?
Well, I think that, yeah, we have had collaboration successfully with Yahoo, Microsoft, others to do protocols. So for example, for a long time, there was a question of how do you crawl the web? How do you find web pages? We collaborated and came up with a sitemaps protocol. Okay. But if you imagine doing a contacts protocol where you say, this is how you access the contacts once you have the user's permission, that makes a lot of sense. And if you could have a standard way of storing those contacts and accessing them, that would go a long way.
Okay, we've got a question from the audience. Do we have a mic for him, or? Okay. Go. Here's your mic. Hold on.
So, well, okay, that's loud. All right. So, like the difference between a traditional CDN and also a traditional CDN and cloud computing for distribution of video assets, photos, and music. Can you just explain the difference between the two?
So CDN is only one particular form of cloud computing. We offer CloudFront, which is in front of S3, which is a traditional CDN in that form. But there's many more things to cloud computing. You can have many more capabilities at infrastructure level as well as you go up into the stack. But there's many things which you cannot do in a CDN as being a platform where you can develop on.
Okay, so just like from a pricing perspective, like Amazon Web Services is much cheaper than going with an Akamai, for example.
So one of the things there, I think what is important, traditional CDNs have this very old-fashioned business model, meaning you have to do upfront commitments, a particular amount of usage that you have to do. I think most of the cloud services have a completely different model, which is pay as you go, only pay for what you use, no upfront commitments, and those kind of things, which makes it suddenly possible for everyone to start using a CDN, where in the past with the traditional CDNs, you had to do these real long negotiations before you could even start using them. Now, overnight, if you use S3, you have your files stored there. Tomorrow you want to use it with a CDN, you can start using it immediately. If you no longer want to use it, you give it up, and there's no commitment there.
Okay, in the front here.
I would like to ask if there are any plans to shift the cloud computing more to users' computers. I mean, right now you're handling the data, the cloud computer in your own data centers, while there is a lot of computing power out there. For instance, we see it in peer-to-peer. We see it in Google Gears, for example, using the local computer as a centralized computing power. Is there any plans to shift it more to the users?
Well, it's a very interesting concept to consider using more distributed resources. But I think one of the things that we really try to achieve with the services that we offer, and whether it's application services or whether it's infrastructure services, is to provide them a very high reliability. And so if you really have to aggregate all these endpoints, it becomes much harder to guarantee that level of availability. Yeah, so we want to make our services available, let's say, indistinguishable from perfect. Yeah, so it becomes much harder to do this with many distributed resources that are, in essence, not under your control. So that's I think, but the concept in itself is interesting.
Yeah, I think that it's the reliability aspect of it, and then also the Pacific Ocean is just really wide. There's a huge part of the day where users are just not very active on these services, on Amazon, on Google, which means we have lots of spare compute cycles to use. So if you have those spare compute cycles, why not use them, right? For example, to render a movie or do things that are not very time sensitive, where you need a lot of compute cycles. And so until those are used up, we don't really need to look to, say, end user computers, which are less under the control of a centralized cloud.
Although where I've seen the model being applied successfully is, for example, within an enterprise. Yeah, so where Ford Motor Company will use all spare desktops at night to run simulations. Yeah? But again, that's an environment that is under tight control of a particular group of system administrators. I think there have been a number of attempts to do storage on worldwide scale. I mean, the churn in users contributing their storage to the overall system makes it hard. But it's a promising concept, and probably, you know, when we're a year from now and we'll be back here, the world will look very different. There'll be new services, there'll be new technologies that actually cloud computing will enable.
Yeah,
It just has to be for services that are not very time sensitive. So for example, we had a version of the Google toolbar that in the background worked with the folding at home people at Stanford to fold proteins and do those computations, but you just could never really count on how many toolbars were going to be on at any given time and whether or not those computers were going to be used for something else. So if it's just sort of an ongoing scientific research project that needs a lot of computation, it doesn't really matter when that computation happens. It's a great solution. But if it's really time sensitive, it's hard to make it work.
I think there's a more interesting thing to think about with devices than being able to use their spare compute cycle to do back-end compute. We think that devices increasingly need to be thought of as cloud connected, that you want to start with the perspective that clouds aren't independent, but they will always be able to and need to be thought of architecturally as critical components of this broader cloud capability. What kinds of things make sense to do on the local device? Again, things like voice recognition, where it's computationally intensive, there's a lot of data that you have to slough around. Being able to deal well in disconnected things. Technologies like Google Gears, Adobe Air, et cetera, that allow you to keep working when the network connectivity is less than perfect. But devices are also, I think, critically the sensor network for the cloud. When you think about being able to understand where you are and what you're doing and what your preferences are, et cetera, the devices are one of the most important sources of that kind of insight.
Okay, in the back.
Albert Thürmann, Omigo, we're actually running our entire performance advertising system on Amazon Web Services because we would never be able to handle the fluctuations in ad impressions, really. I don't want to handle servers, it's a pain in the ass. So. But the question really is that people often ask me, you are losing a bit of control by moving into the cloud. You have loads of reliability, and yes, you will be up, and you're a lot better at keeping servers up than I will ever be. But still, you lose that control of having 2 data centers or something. What do you tell people that really are a bit afraid still to losing control about their hardware?
You know, that's something you have to come to terms with. But in general, if you see the kind of interfaces that we're using for this are ones that, in general, customers are already very familiar with. You use standard virtualization, standard virtual machines. So, you know, between running your own virtual machine in your own environment versus running it in Amazon is a small step for many. But I think there's, in history, multiple points where we've given up more control. Yeah, in the older days, when we did mainframes, most companies maybe even wrote their own operating system. Yeah, because you wanted to have complete control over every piece in the stack. You know, you would write your own middleware. Now you buy a middleware. So everything goes up in the stack in terms of giving up control for additional services. And in this case, you know, if you want to have better reliability, better availability, better scale, at a much better cost point, you give up a little bit control to actually achieve that. One of the feedback that I get from a lot of customers is that, as you say, availability is much better than that they could achieve for themselves. But also security is much better than that they could achieve for themselves. Yeah? If you see how many people still have all their servers located in colo environments, they don't know where the servers are, they don't know who have access to them. Actually, moving your services, moving your computation, and moving your applications into the cloud gives you a much better security model than what you used to have by doing it yourself.
I mean, I guess if I were you, what I would say is we can always take control back. Yes, you're surrendering a little bit of control, but if in the end it becomes economically the right thing to do, or for other reasons the right thing to do for your business, you can always choose to build your own data centers and, you know, and your own compute halls. As I said, from my experience at Google, it's really hard, and you actually want your talent focused on something else, thinking about what's the great next new idea or how to improve the application. That's a better place to put the focus of your talents rather than trying to understand which machine needs to be rebooted and what scripts you're going to write to monitor them all, right? But you always have that as an option. So while you're relinquishing a little control, you can always take it back.
On that note, I'm afraid we have got to go because our time is out. So thank you all, and go use your cloud computing capabilities and have a great day. Thank you.